Okay, here we are for the second part of our 1.3 quantitative data numerical summaries. And now we're going to take a look at standard deviation. So this is the measurement for spread that is used most frequently. We hear about it in a lot of different areas. And as we learned, the interquartile range and the range each have their place and their usefulness, and the interquartile range sometimes is actually more appropriate to use in the standard deviation. However, standard deviation is more commonly used. Now, what we're going to do is we're going to start out with a small set of data, 9 pieces of data, so that you can actually see how the standard deviation is put together. So there was a survey for with elementary school children, and 9 children were asked how many pets they own. So here is the dot plot of the data of the answer to that survey question. How many pets do these children own? There are 9 pieces of data. And you can see that they range from 1 to 9, which is a lot of pets. So the first thing that we're going to do is find the mean of this data. Now just remember, when we look at this, we're going to add up the numbers 1, 3, 4, 4, 4, 5, 7, 8, and 9, and then divide by 9 because we have 9 pieces of data. So that's the first thing that's going to happen. And then we're going to find the difference between the mean and each piece of data. And sometimes the mean is going to be higher, sometimes the mean is going to be lower, but we're going to find how much the difference is from each individual piece of data to the mean. Okay, so we calculate our mean. Our x bar or mean is 5. And for the first data point, we do we do the individual data point minus x bar, and we get a number -4. So what that means is negative, it's below the mean, and 4, it's 4 away from the mean. And we're going to continue to do that for all of the different pieces of data in our data set. So each time it's going to be the observation or the piece of data minus the mean. We're going to do that for all of the values. And if we added them all together, what will they total? The total is going to be 0. So finding the difference and knowing that we want to find the standard deviation or the average difference away from the mean for this data set, the average difference from the mean for each of the data points for this data set. We can't do it by just finding the deviations or the differences and then dividing by the number of differences, because we end up with 0. So what we're going to do instead is we're going to square the differences. And after we square them, we're going to add them up. Then we're going to divide by n, the sample size, -1. And then we're going to square root the whole thing. The squared version is called the variance. The square rooted version is called the standard deviation. So we end up with 2.55, and it's the standard deviation for this data set. There's only one mean for the data set. There's only one standard deviation for the data set. And we want to be able to interpret it. And our interpretation is, on average, the number of pets the school children have is 2.55 away from the mean. And that means, again, it can be below, it could be above, but that is the average deviation from the mean for our data set. So once again, the standard deviation measures the average distance between each of the observations and the mean. And we calculated it, as you saw, finding the difference, squaring, dividing, adding them all together, then dividing by n-1, and then taking the square root. So the average square distance is the variance. You can see the formula here. This is a formula on your formula sheet. Standard deviation is when we take the square root of that. There are actually 2 standard deviations that our calculator will calculate for us. One of them is a standard deviation of a population. That means all of the individuals in our set of interest. And the second one is a standard deviation of a sample or a subset of a population. So we'll take a look at that in class so that you can see what the difference is in the symbol, and you can see how we choose each one. We'll be talking about that ongoing. All right, when we have two different measurements for center, mean and median, and two different measurements for spread, standard deviation and interquartile range, we have to be able to decide which one is appropriate to use when. And what we find, we understand that mean and standard deviation go together because we used the mean to calculate the standard deviation. We understand that median and interquartile range go together because the interquartile range, we had to find the median first in our data. Remember our ordered set of data, and then the Q1 and the Q3 are both the medians of their half of the data. So we understand that those go together as well. So how do we choose between them? Well, what we find is that when we have a skewed distribution, either skewed left or skewed right, what ends up happening is the mean is strongly affected by those extreme values. And so we don't want to use the mean in those cases because it doesn't really give us a good sense of what's going on with the data. And since standard deviation is calculated using the mean, that one would not really be appropriate either. So in those cases, when we have skewed data, we're going to use the median and the IQR. When we have approximately symmetric sets of data, the mean and the standard deviation are the measures that we're going to use. And what we find is for reasonably or approximately symmetric distributions that don't have outliers, the mean and the median are very close. And because of that symmetry, we know that the middle value is going to have the same number as the arithmetic mean, or very close to it anyway. So even though most of the time we're going to be seeing out in the world mean and standard deviation, because we're a little bit more educated now, we know that they're not always the most appropriate or the most beneficial to use to describe the data. So one of the things that we're always going to do is we're going to remember that just because we have numbers that describe our data, there is really no substitute for graphing our data and seeing what it looks like and having a good understanding of the behavior of our data set. As we go through the year, there is a 4-step process that we're going to be using for problem solving, and we really need to start using it later on in the year very carefully and thoroughly, but for right now we're just going to introduce it quickly. We're going to call it the 4-step process, and when you look in your textbook, you'll see some of the questions have what looks like a little stair step on them, and that's for the 4-step process. Step, get it? Stairs. The first part, state, part 1, what's the question that you're trying to answer? The next part is part 2, and that's the plan. How do we go about answering the question? What statistical techniques do we need to use? It's going to be a little bit more formal when we put this together. You'll see later on in the year. Part 3 is what we're going to call do. This is graphs and calculations, and then conclusion is going to be where we actually do an interpretation, a real-world interpretation with our supporting evidence. So as you can see, statistics is a little bit different than some of your previous math classes because the calculation part, the do, is only about 1/4 of your answer. That brings us to the end of section 1.3. And you can see the different things that we have been able to accomplish through this section. I know it was a little bit long and a little bit detailed, but having a really good foundation in this section is going to pay off for the remainder of the year. So definitely bring questions to class. See you then.